Welcome to the project demonstration of solar buck boost with MPPT using PIC microcontroller. The main application of this project is in order to charge up to 12 volt 1 amp battery pack, we are using a 12 volt 3 watt solar panel. So when we are using a 12 volt solar panel under the sunlight, it can generate up to 18 volts of power supply, which is in a maximum voltage generation from the solar panel. But our battery charging voltage is 14.5 volts maximum, 14 volts minimum, 14.5 volts maximum. Then only we can charge this battery pack. Coming to the battery pack, we are using 12 volt 1 amp, and in this one 3 4 volt 1 amp batteries are connected in series, so we'll get 12 volt 1 amp. So for that 14.5 volts maximum charging voltage. So when we are using a 3 watt solar panel under the sunlight, so the 18 volts is maximum voltage, but in order to compensate the power equal to 3 watts, then the current will be decreased. So as we know that P equal to VI, when the voltage is increased, the current will be decreased in order to maintain the constant power of 3 watts. So in order to get this maximum power with maximum voltage with maximum current, we are using the MPPT, that is the buck converter along with the boost converter. So the buck converter is, so whenever the voltage of the solar panel crosses the 14.5 volts, then the microcontroller continuously measuring this voltage from the solar panel, and it will make the buck operation with help of this buck boost converter to get the 14.5 volts there. Then as we know that 3 is a wattage, 3 equal to 14.5 into the current, same value, means the current will be getting the maximum current, so that will get the maximum power, and that will be continuously monitored on this 16:2 LCD along with the MPPT concept. And coming to the boost operation, whenever the solar panel voltage is above 8.59 volts, then the system will boost up that up to 12.5 to 14.5 based on the availability of voltage from the solar panel. It will boost up the voltage. The minimum voltage for the boost up is 8.5 volts. Then only with the boost operation can be possible to make that voltage to the 12.5 above, below 14.5. So this is the buck boost operation with help of PIC microcontroller for the solar power supply. So the power flow is, so we are providing 12 volt solar panel parallel to the voltage sensor and to this charging circuit. So here the charging circuit purpose is, whenever the battery voltage is fully charged, then if the sunlight is not available on the solar panel, this charging circuit will block the current flow from the battery to the solar panel, so that we can protect the source. And also the LED indicator, the output from this charging circuit is input to this buck boost converter along with MPPT operation will be done with help of our PIC microcontroller. We are using PIC 16F73 microcontroller, and output of this circuit is input to the battery pack for charging purpose. So we have the secondary source whenever the totally sunlight is not available in order to charge a battery pack. So this is a transformer, will take 230 volts AC input and provide us the 12 volts DC, 14.5 volts DC output directly to this battery for charging purpose. So now just on the power supply to the transformer, the light will be indicated as an indication of the battery is charging to the transformer. So before demonstration of this project, we should keep the battery under charging either from the solar panel or from the transformer. It will take 3 to 4 hours to be fully charged. Till the duration, keep the battery under charging. And then after coming to the utilization of this power charging inside the battery pack to this DC load directly, just by on this we can utilize the power. So this is a main switch on this battery pack. We can on that and we can utilize that power to the load directly. On LCD we can see that solar panel voltage. So as of now, low lighting, just be placing the more lighting torch lights, then you can see the voltage got increased, right? Okay, so when we removing this, the voltage will be decreased here. So whenever the voltage is increased, as we can see, the SV nothing but solar voltage, BV nothing but battery voltage, and this one is the main output voltage will be preferable from the solar panel MPPT, and this is 0 nothing but the MPPT PWM signal. So whenever the voltage crossed, then this will be increased. Okay, right. And when we remove this, you can remove this, and you can see the battery voltage is 0, and we can connect this. So this is the battery voltage sensor, and this one is a solar voltage sensor. Coming to the battery voltage sensor and solar voltage sensor, we can see two resistors which are used as a potential divider for voltage measuring purpose, as we are using the 10:1 10 kilo ohm and 1 kilo ohm as a potential divider circuits to measure the voltage, right? So these are the main components: transformer, charging circuits, microcontroller and battery. Thank you.